Pydantic AI composes agent behavior through a capabilities mechanism that bundles tools, instructions, and lifecycle hooks into a single, reusable abstraction, letting you avoid threading configuration through scattered constructor arguments. The code below demonstrates how two MCP servers are registered under distinct name prefixes, so their tool sets remain unambiguous during a run. The agent is initialized with PrefixTools, wrapping each MCP capability, specifying API 1 and API 2 as the respective prefixes applied to every tool name exposed by those servers.
From Pydantic AI Import Agent. From Pydantic AI, capabilities import MCP, PrefixTools. Agent equals agent. OpenAI, GPT-5 2. Capabilities equals. PrefixTools MC Perl equals HTTPS//API1. Example, com, prefix equals API1. PrefixTools MC Perl equals HTTPS//API2. Example, com, prefix equals API2.
Agent wired with two MCP servers, each namespaced via PrefixTools with API 1 and API 2 prefixes. This is the standard way to compose multiple capabilities that expose tools with potentially colliding names. The prefix gets prepended to every tool name the model sees, so API 1 get user and API 2 get user coexist without conflict. Without the prefix wrapper, two MCP servers exposing identically named tools would collide in the agent's tool registry. PrefixTools is a thin wrapper capability that delegates everything to the wrapped capability while transforming tool names at registration time. You could also call PrefixToolSAPI1 on the MCP instance directly. The wrapper pattern just makes the composition explicit in the constructor list. Let's break it down line by line.
From Pydantic AI Import Agent.
Imports agent from Pydantic AI, the central class for constructing an AI agent instance.
From Pydantic AI, capabilities import MCP, PrefixTools.
Imports MCP and PrefixTools from Pydantic AI's capabilities module for connecting to model context protocol servers and wrapping tool names with prefixes.
OpenAI, GPT-5 2.
Specifies the OpenAI provider with the GPT-5 2 model as a string identifier in provider model format.
PrefixTools MC Perl equals HTTPS//API1. Example, com, prefix equals API1.
Wraps an MCP server connection at HTTPS//API1. Example, com with tool names prefixed by API1 to avoid naming collisions.
PrefixTools MC Perl equals HTTPS//API2. Example, com, prefix equals API2.
Wraps an MCP server connection at API2. Example, com with the prefix API2, so all tools from that server get namespaced under that prefix to avoid naming collisions. The whole point is that agent composes behavior through capabilities. And when you have multiple MCP servers exposing tools that might share names, PrefixTools namespaces them at registration time, so API 1 get user and API 2 get user coexist without collision. The prefix wrapper is a thin capability that delegates to the wrapped MCP connection while transforming tool names. You could call PrefixTools on the MCP instance directly, but wrapping it in the constructor list makes the composition explicit. The provider model string just picks the model, and the capabilities list is where all the wiring happens.
The prefix guards two unnamed MCP servers, and the agent knows their name.